Good morning, everybody, or close to lunchtime. So I'm happy to be here again. So it's not my first time. I hope you're not tired of me already. No. Okay. So Uni said I will talk about PubSub today a little bit. I had a PubSub presentation like I think 2 years ago already. This is finished now, so I talk a little bit about PubSub, but especially about what's coming next and what we just finished and what we will work now on. So the first is just to give you like a status update overview, like where OPC UA stands at the moment, then a status update on OPC UA over TSN, which is a fairly hot topic at the moment. Then I go into some details of what we are working on for OPC UA over TSN, especially in the configuration model for TSN in OPC UA PubSub. And then also some outlook what's coming next and what will be announced or was partially announced already, but there will be more announcement about that. So we heard that already today. The core of OPC UA is information modeling. There's like everything, like what VDMA is doing, what FDI is doing, what a lot of these collaboration working groups are doing. They rely on the base capability of OPC UA to describe information in a rich, self-describing way. And that's what we call this OPC UA core information modeling capabilities. Then for the communication part, we have two different communication models. Like what Uni already said, the client-server model we have since the very early days of OPC, since more than 20 years. And we have that also from the beginning of OPC UA. The client-server model is the communication model we started from. But we realized over the last few years that we need also a publish-subscribe communication model to fit like especially large scale use cases, high performance communication use cases, low latency communication, also especially cloud communication. And then we have protocol bindings. So we always separate the communication model as general concept from the actual protocol bindings. So protocol bindings can be added, removed, deprecated. So this is more the dynamic part of OPC UA and the communication side. But the good news is you don't care about these details. That's done by the OPC Foundation side. And so if FDI and VDMA are talking about OPC UA, they just assume this is just working and will be further developed and enhanced. And so this is the responsibility of the OPC Foundation. And that's what you already know as IEC 62541. As IEC version. And then, like mentioned before, we work with partner organizations like VDMA, like FDI, to develop these companion information. So they are either domain specific, like FDI is like process industry field device integration, or machines type or device type specific. So we have working groups like the Auto ID working group, doing interfaces for barcode readers, RFID readers, or like the machine types with VDMA, like injection molding machine, machine tools, woodworking machine, all kind of different machine types. From the timeline, you see there was like the first official release that was like where it's possible to really release products was 2009. And then since then we had like in a 3-year cycle we had additional releases. In the early days we completed feature sets that were not finished in the first version, and the big step, adding really a big new feature like for the PubSub configuration communication model, was done in end 2017 and early 2018. You asked, was it last year, this year? Most of the specs were finished end of 2017, but PubSub was finished in March 2018. That's why I said both is true. And for the 104 release, like I said, PubSub was a big chunk of the work we did, but there were also a lot of minor enhancements, clarifications, So every release there's also a lot of enhancements for certification and testing, because every spec is only so good the more you test and the more you implement the specification, the more flaws or details you find that you need to further clarify. But like I said, there is some things we had to change or enhance. So security is always a moving target. So I always say security is always a maintenance piece. You have to maintain it in the specifications, in the implementations, and also in operational environments. You need to maintain security. And what was very like something that was especially important on dealing on very dynamic and complex systems, like where you have a lot of data structures. We changed the way how you expose the information, how a structure is encoded in OPC UA. We added some new features for the client-server transport. So we added a WebSocket binding for web applications. We added a JSON encoding that's also related to web applications. But we also added a reverse connect capability. So that allows to establish the TCP/IP connection from server to client, but then do the rest of the logical connection establishment from client to server. So you can, if you have a firewall you can connect from server to client, but not from client to server in terms of a TCP/IP connection. This can be solved. And so one thing here, we have sessionless service calls. A big chunk of work was also related to user management or user authentication. So in OPC UA, we always had standard tokens, like a way you send user information from a client to server, like username, password, certificates, anonymous. And one thing we added was like a new token type, but more important, we also defined the user authorization, so defining a mapping of users to roles, to expose roles in OPC UA servers, to manage roles through OPC UA, and also to manage permissions. So what is a role able to do? Like on a set point, observer can maybe just read it, and the operator can also write it. And you can configure that now also through standard OPC UA mechanisms. So it was always possible before to manage that with OPC UA, but like the access to it. But now it's also possible to manage the backend. So how you configure the permissions on a node, how you configure roles, how you map roles and permissions together on nodes. So this is now also standardized. We extended the alarm model for more, like covering more alarm standards. We extended file transfer, and we also defined new network services. So we have, like in OPC UA Part 12, we have concepts for centralized security management, and so we always add new services if we need some feature in this centralized management part. But like I said, the biggest feature add was OPC UA PubSub. And like I said earlier, we always differentiate between the overall communication model and the transport protocol bindings. And the overall communication model in PubSub defines how you map information in an OPC UA information model, like variables, events, into messages that can be sent over a PubSub messaging system. So the generic part is how you select variable lists to create what we call a data set, or to select events, to filter for events that create a data set, and to add metadata to such a data set. So it's a data set is a list of named values, but you can maybe want to add a unit or range for the receiver, and this metadata can be exchanged independent of the cyclic exchange of the data set. And then on the protocol side, we have different encodings. So you can encode data sets into binary format with some OPC UA defined headers, or in a JSON format, which is like suitable for IT applications that do not know anything about OPC UA encodings. And then we can send these messages over different transport protocols. So for the local or peer-to-peer communication, we have UDP. You can route UDP, but I assume most of the use cases will be local use cases for UDP. But you can use UDP multicast. Ethernet is we have a raw Ethernet binding, an ether type defined, and that's probably mainly used together with TSN enhanced networks. Then we have two protocol bindings, more like for the IT integration and cloud connectivity, like AMQP and MQTT. So most messaging systems today support these standard messaging protocols. So what is the status of OPC UA over TSN? So for OPC UA over TSN, we need a stack of standards. So it's not only OPC UA, there are different parties involved. And the lowest layer is IEEE. So they define the Ethernet standards. And TSN is not a new standard. TSN is just a set of extensions to standard Ethernet. And Ethernet, the 802 working group, has just different sub-working groups that work on important features for real-time networks. And most of these essential parts are already released, but there's one little tiny detail called time synchronization that's very important for real-time, and that's not, maybe it's finalized, it's very close to be released, but last time I looked, it was not released yet. And there are some other pieces that are maybe of interest in industrial profiles, and they're still work in progress. There's a second important group, and it's a joint working group between IEEE and IEC. It's the 6802, and they work on the industrial profile for use of TSN in industrial environments. And that's an important work because the idea of TSN is that a lot of different real-time services share the same network. And that's different what you have with Ethernet-based field buses today. You can only run one Ethernet field bus in one network. And how you can run in parallel IT traffic depends on that Ethernet-based field bus. And the idea with TSN, and that's completely independent of OPC UA, is that you can run different protocols that require real-time capabilities plus IT communication on one network. That's the basic idea. And to make that real, you need some basic rules that everybody agrees to and applies to. And that's what is the work that's done in this joint working group. And like I said, this is a working group that is active at the moment. So they're in the middle of the work. Then we have on top of like one of the protocols and real-time services that is used on this TSN network will be OPC UA PubSub. The PubSub messages, especially the Ethernet binding. And this is released since March 2018. So this is finished. So in theory, you can already use OPC UA over TSN. The problem is we define the payload, the data plane, but how do you configure TSN? So how do you configure the endpoint with all the timing parameters, but also how you configure the network, and how do you line up the network configuration with the device configuration? And so one thing we work on in the OPC Foundation is to specify the TSN parameters. So one part is the quality of service parameters that is necessary as information to the network to do the scheduling, but also the information that comes from the scheduling back to the OPC UA application, how to behave and what kind of network path and timing to use to send messages. So this is we have a draft document for that is currently under discussion, and the next step will be prototyping of that draft to go to a release candidate state. Then we have different, like more specific applications running over OPC UA over TSN, and that was one of the early requirements for OPC UA over TSN is to be able to act as a black channel for safety. And there's one working group that started in February this year that defines how Profinet would use OPC UA TSN as a black channel for safety communication. And then we have a lot of the device and companion specification use OPC DI as a common concept. And since there is a lot of requirements from these working groups, we also started a new revision of OPC DI. So we already, like 2013, we have the version 101 that is also IEC, available as IEC standard. But we are currently working on the 102 to add more features. Some parts are clarifications, but also others are also to support the whole life cycle of a device. So things like firmware update or parameter backup restore features we work on, or security management of the devices. And then we work, like what was mentioned before, we work with a lot of working groups, companion working groups that also have real-time requirements. So one example is Euromap 79. So it's defining a communication between injection molding machine and robots. And there's a lot of information exchange necessary, but at the end of the day, they need to exchange position signals, and these signals need real-time behavior. And a lot of the companion specs at the end of the day represent devices that need to talk to controllers. And even if maybe 95% of the information goes to the IT level, there's still very important real-time signals that need to be exchanged with the controller. So a lot of these specifications have some requirements for real-time and looking for OPC UA over TSN support. So how does this OPC UA PubSub and TSN comes together? So this is the PubSub configuration model. So we have on the left side you see the objects in the model and their relation, and on the right side you see like the network side representation of messages. And you have, like on the connection level, you define more or less, you select the protocol and the encoding, and that defines also what is the transport protocol specific header. So in the case of Ethernet, it's just the ether type. In case of UDP, you have a UDP IP header. And in case of MQTT, you have a MQTT protocol header. And then what we call network message is the OPC UA payload. And this is defined by what we call rider group. So that has mainly the timing and like the cycle time and also like transport and message specific settings. And then the actual the application data goes into this dataset message. And so this is really the information that is application related. And if you look at the overall communication, we have a publisher that sends network messages containing these data sets through a rider group. So the rider group has all the sending settings for these network messages. And then we have subscribers, and in OPC UA always one publisher can send messages to n subscribers. And on the subscriber side, you have a reader group. And then if you link that to a TSN network, the terms used in TSN is TSN talker for the sender side and TSN listener on the receiver side. And the logical connection between the talkers and the talker and the listeners is called TSN stream. And there's also one-to-n relation. So one talker can use a stream to send data to n listeners. And in OPC UA, we need to mapping of like the TSN layer into the configuration model and the data plane. So the network messages from a group are sent through a TSN stream to the listeners and therefore to the subscribers in OPC UA terms. But what we need on the configuration model, we need representations for the network interface. So maybe you need to select the network interface, or maybe you need information about the capabilities of the network interface for scheduling purpose. So the network configuration needs information about the network interface. And then we need also representation of the stream objects to link the writer groups, the sending to the streams, and also on the receiver side. And the streams contain like addressing information, but also timing information. And so this is what we work in the OPC working group for the TSN parameters, is to represent these TSN constructs and the quality of service parameters in the OPC UA PubSub configuration model. And the challenge we have at the moment is there are two network side configuration models discussed. There's what's called centralized configuration, and the concept of the centralized configuration is you have different switches making up the network, and then you have one centralized scheduling component that is doing the network scheduling, and then you have a protocol-specific component that is providing the communication to maybe engineering or to the endpoints in terms of OPC UA publishers and subscribers. So in this case, the communication is to the network configuration is protocol specific, and the distributed configuration model, the concept is that the application specifies the communication requirements down to the network stack, and then the network stack is talking to the network, to the edge bridges, and they do the interaction with the whatever is the scheduling system, or either they do ad hoc scheduling or they talk to a centralized scheduling system. But the concept is that the network driver is doing the interaction for the configuration. And in terms of OPC UA configuration model, we need to be able to cover both scenarios. And so we have multiple ways that you can configure OPC UA PubSub over TSN, so the TSN side, or also the PubSub parameters. One is that you just provide an offline configuration. So you have an engineering tool, you provide an offline representation with all the parameters, so everything is pre-engineered and known at startup. So you can provide that as a configuration. We have a standard format for a OPC UA binary encoded format for the configuration. You can use the client server model, and that's also like for the pre-engineered case. You can download the configuration through the standard OPC UA PubSub configuration information model. Then we have the interaction with the centralized model. So in this case, there are OPC UA messages exchanged between the endpoints and the centralized configuration system. And the fourth variation is that you get the interaction with the network configuration through the network driver. But at the end of the day, the parameters, the quality of service settings, they are represented always the same way. That's the basic idea of what we are working on at the moment. So to make the OPC UA model independent of the network configuration model. So, like I said, this is the detail we're working on in the OPC Foundation side at the moment, on the TSN side. And then to give you some outlook, what is the timing and things that are coming up at the moment. So if you look at the regular release cycle, so we didn't plan that, but if you look at the cycle, it's 3 years. So you can guess whatever we do, the next release will be in 3 years. So it's 2021. And if you ask people, so like if you ask FDI, do you want to wait for the semantic, for the data dictionary integration for 2021? Probably not. You need it now. So what we decided is, it's not only FDI. We have a lot of working groups that always come up with smaller feature requests. Some are bigger, like TSN, but also a lot of them are very small extensions. So what we decided as the OPC UA working group to really cover these short-term requirements and to be able to deliver something in probably 3 months, half a year, is to have amendments to the OPC UA specification. So currently we have 104. So what we release as amendments is part of 104. We had already always errata. So if something comes up with our spec, we publish an errata document. But now we also publish amendments. And there's 3 already released. So we have one where we extend especially the analog item type with units and ranges. We have some extended concepts there that is released. We have something for providing more metadata for a method. So for example, that you can provide a range in a unit for a method parameter. So it's to have much more capabilities of providing metadata for single method parameters. And then this, I think, came out of the robotics working group from VDMA, is we extended the state machine model with new, with choice states and guards. And then we have security is always a topic that needs to be faster enhancements. That's what FDI is looking for, the reference to external data dictionaries and semantics. That's what Achim mentioned in his presentation. This is for PubSub, more specific header profiles. So what really, for different use cases, what is exactly the header layout that's used for that use case. And that's more on the information modeling side, interfaces and add-ons to add concepts that are used from object-oriented programming to provide them in OPC UA. And the TSN configuration model is the big topic we're working on there's a separate sub-working group for this one. And then the latest news, this is came out just, I think, last week as a press release. So far, the OPC Foundation concentrated for OPC UA over TSN on controller-controller communication. So that was the scope always. There was already a lot of discussion about using OPC UA over TS also on field level. And that was a very controversial discussion, as you can imagine, with all the field buses that exist today. But there was after the result of that discussion that was over the last year, is that the OPC Foundation decided to start initiative to also work with OPC UA over TSN down to the field level. So that was announced last Monday. There will be new working groups that will be started, I assume early next year, that will standardize on all relevant topics that are related to field device communication. So one is, first of all, is to harmonize or look at existing systems and harmonize the features there in terms of how it can be used in OPC UA. And that includes I/O profiles, motion safety profiles. Then to standardize these harmonized things in OPC UA information models that are dedicated for field devices, for online and offline configuration, and then to map that to OPC UA and TSN specific scenarios. Because both OPC UA and TSN, they bring new aspects to field communication. So this is the scope, and then for sure there is also a definition of the certification part. So that was very important for most of the vendors, or all of the vendors that joined that initiative, that there will be a certification program from the early beginning. And that was also very important for everybody, is to align with this joint IEEE IEC working group that is working on the TSN profiles for the industrial automation. There will be more details announced at SPS IBC Drives, like in 2 weeks. There is a press conference there, and there will be much more details provided. And the new working groups are expected to start early 2019. So there will be a call for members to going out to the OPC Foundation members. I assume sometimes end of November, beginning of December, for kickoff meeting in January, I assume. That's still under preparation, everything. So this is a big news for the OPC Foundation. And it took a long time to make that decision as organization. Okay, so that's my update and related OPC UA in general and PubSub and TSN in special.